Hi and welcome to Test Break and Learn. Today I will do some quick experiments. I asked ChatGPT to give me a sort of curriculum and I'm gonna follow that and today do the first part. And let's get right to it then. Okay, so this is what I got. I got a few questions and instead of ChatGPT just giving me the answer, I went ahead and tried to form my own words and opinions about it. So the first 4 questions was what is voltage really? What is current really? What is resistance really? Why do they depend on each other? And voltage, it's what creates the push that makes electrons move. Voltage is not dependent on a continuous circuit, can exist anyway. It's the potential difference between two points in a circuit. Current, it's the rate of electrons. Current is the result of the amount of voltage and resistance in a circuit. And current, there's no current if there's no continuous circuit. And resistance limits current. It turns electricity into heat. A good conductor, like copper, conducts electricity very well, and a good conductor has low resistance. If it has a high resistance, it does not transfer current very well. Almost everyone knows that glass, for example, if you don't know anything about electricity, you know that glass won't transfer electricity. And how they depend on each other was discovered by a guy named Georg Simon Ohm, and he discovered in 1827 the relationship between volt, current and resistance. Current moves through a circuit with some degree of friction, and that friction comes from the resistance, and voltage affects the amount of current that can flow. So if you increase the voltage, you can have more current. If you increase the resistance, you get less current in a circuit. So the first experiment is quite easy. I have my power supply, multimeter and no load. We're going to measure current and voltage. You can start by measuring voltage. And before I measure, I have my supply set to 5 volts. So 5 volts output, and this will show 5 volts. 5.03, so it's 5 volts. We're gonna measure current. Let's do milliamps, just one. And there's not gonna be any current. There's no circuit. The current I can measure here is going through my multimeter. So it's 40 milliamps. At this moment, the power supply has no, I can see it on the display, it draws no current. When I put this here, my power supply says 60 milliamps. So there's a difference there. This one was very cheap. I saw today when I started testing it out, I'm missing a important unit to measure. I can't measure capacitance. I can't measure capacitors. I missed that when I ordered this one. Okay, so Maybe I will order another one and I can compare them. But this one shows it's like 50% difference. Let's increase the current to 100 milliamps. Okay, so it draws a lot more power. I don't like this about this part. It actually says that then my multimeter draws a lot of current. I'm suspecting it because of the impedance inside. Okay, so the question was, will there be voltage? Yes, and I have written down here. Okay. No load, no current. I wasn't expecting my instrument multimeter to draw that much current. Voltage will be the same as the power supply is set to. And experiment number 2, I will have a fixed voltage, LED, and some resistors. I have some different resistors here. I have a 220, a 1K, and a 10K. Yeah. I will use 5 volts LED. So first I will measure the current. Okay. I will measure the current. Test it. Not drawing any current. I think it should say it's drawing current. I think there's a bad connection somewhere, because this should draw current. Okay, let's skip this and just I don't know if you could see, but I could see there was a small, there's a small line. Maybe you can see like this. Okay. Yeah, it shows. But it's too small for to measure any current. So this is the 220. So this is 220 ohms. It should be much brighter. Yeah, okay. So let's try this one out like this. Okay, so now we have 10 milliamps. My power supply says 14 milliamps. I wrote down some numbers here. 220, I was guessing 13 milliamps with this calculation. I used 2 volts as a forward voltage over the LED. I had these ones for 10 years in a box. I don't remember exactly the forward voltage since it only transfers current in one direction. It acts like a diode. I didn't do anything beforehand. I just looked up on the internet, and it said about 1.6 to about 2 volts. So I just used 2 volts. To get the current, you take the remaining voltage divided by the resistance. And first you have to do the power supply, supplied voltage minus the forward voltage divided by the amount of current you expect to have. I did the other way around. 0.3 milliamps for the 10K. I didn't measure anything. Let's do the 1K. 2 microamps, which is 3 milliamps. Okay, I don't know the color coding. So let's measure this one. So this is 1K. 10K. 1K. Okay, I had one of each. 3 milliamps was my guess. Pretty close. And since this one for measurement was not the best, I'm gonna take it as a win and say I was correct. So the last experiment for now, I'm gonna use the same voltage, a low value resistor. I'll just disconnect this. So the test is the same voltage, low value resistor. I will use a, not 10, yeah, 10, okay. So a 10 ohm, and I have this one for measuring temperature. Okay, sounds pretty accurate, 22 degrees. Okay, so we're going to power this on, measure the temperature. Maybe it will burn. I can set the power 200, maybe 200 milliamps maximum, and I will try and touch it. I will measure first, just to see how did it get. So yeah, here we go. So it draws 200 milliamps right away. 26, so it gets hot quick. It's hard to get an accurate reading with this one because there are a lot of points, but 38 degrees, I will just turn it off here. Actually, I can't feel anything, but it got hot very quick. I haven't wrote down anything about what did happen yet, because it hasn't. It got really hot, not so I can touch it because I turned it off. The energy flowing through this, it's a circuit, so it will just be heat. It's just loss of energy. Maybe it didn't do much, this experiment. I found out that this one is not accurate. It draws a lot of power when measuring current. It's not a high precision instrument. I will do some tests like this, and I will post them here. So this is the roadmap that ChatGPT gave me. So I will try and follow this to some degree, maybe not exactly everything. This is just a test to see if I can be consistent and document what I do. Maybe not everything will be a video. This is a way for me to understand a little bit better for myself, or at least to remember what I read and test and do. Maybe not the most exciting, but for me it showed that I need to read better what I order, because that one is kind of a waste now. And by the way, the power supply, also new one. It's a Joyit JT RD6006. It did not say anywhere when I ordered it. It wasn't assembled. There was no instructions. Felt like parts missing, but they weren't. I didn't mind putting it together. Quite fun, because now I know what's inside. But the Joyit, it's not the entire power supply. It's just the part that regulates a 0 to 60 volts power supply. But everything was in the the package. When I tried to look it up from other sites, you had to order the other parts separately. For me, they were included. So far, no problems. This is all I've done so far with it. I've tried to lit some LEDs up just to see, turn it on and off. But this one, I will look up a new one, a more accurate, so I can measure capacitors, because that will be included in what I want to learn. I don't have anything more for today. So go to the link, check the post out if you want, leave a comment and say how bad I am, or if you enjoy this. This is Test Break and Learn. Bye, see you later.